Well, if you want to download this PDF, let me know. I'll post a link in the description. All right, so this is the first type of FRQ, as we know that the pattern has changed for AP Physics 1 and C, both mechanics and E&M. So this is the FRQ type 1 called mathematical routines. There are 4 in total, so we're going to cover all 4 but in separate videos, of course. Okay, a system is comprised of two objects A and B which interact with each other through a conservative force FBA, where x is the position of object A with respect to object B. The potential energy UBA of the two object system as a function of x is given over here. So this is the how the potential energy of the system, is changing, and there is no external force that is exerted on the system. Okay, object A has a mass of ma and is released at 3x naught. So there you go, 3x naught. And it starts moving and later passes to x equal to 7x naught. This is 7x naught. You have to derive an expression for the speed of object A at the instant when object A passes through 7x naught. We have to keep our answer system in terms of ma, u naught, x naught, and any other physical constants. Begin your derivation by writing a fundamental physics principle and an equation for the reference. The physics principle that we are going to use, because we know that the only force acting is a conservative force, right? And there is no other force. So we are going to say that since there is no non-conservative force, the total mechanical energy of this system is conserved which means that the change of, or I can write that initial kinetic plus initial potential is final kinetic plus final potential energy. That's the statement that we're going to start with. So let's conserve the energies, obviously between 3x naught and 7x naught. So we are going to say that the kinetic energy at 3x naught plus the potential energy at 3x naught is equal to the kinetic energy at 7x naught plus the potential energy at 7x naught. Kinetic energy at 3x naught is 0 because the object is just released. A potential energy at 3x naught is the total energy is just we can read it from the graph, right? It's just 2u naught. So this is 2u naught. Kinetic energy at 7x naught is our interest. So half ma v square, where v is the unknown, plus the potential energy of the system at 7x naught is clearly negative 3u naught over here. It's just a matter of rearrangement. Now adding 3u naught both the sides, this becomes 5u naught is equal to half mav square. Multiplying with 2 both the sides, it gives us 10u naught is equal to mav square, and the value of v finally comes out as 10u naught over ma, obviously with a square root on top. So this will be just asking speed, right? Uh, yes, they are just asking speed. Yes, so we don't have to bother about the direction. Right, the next one is on this grid, we need to draw the graph of the force exerted on the object A by object B. So we know that the conservative force, let me want to bring this guy over there as a reference. Okay, the equation that we are going to use over here is, I hope you know, this is very important, that the conservative force is actually negative of du over dx. We'll use the potential energy of the system. So basically, we need to find the derivative of u and put an extra negative to get the force, the conservative force, right? So we very well know that obviously derivative is nothing but the slope, right? So this is a zero slope. So till 2x naught, there is no force because the slope is 0. So I'm going to start by drawing a 0 line, the line at x equals the line on the x-axis, I mean, till 2x naught. And then we have a slope here, which is pretty straightforward because that's just a straight line. So let's use a rise over run. So there is a rise, or rather a fall of from 4u naught. We are falling to negative 4u naught. So that's a fall of negative 8u naught. And there is a run of from 2x naught to 6x naught. 2 to 6 is 4, right? 4x naught. So this is negative 2 u naught over x naught. So negative 2 u naught over x naught is nothing but the force. But remember that although this is negative, but we are going to put another negative because of this formula. So the force when, I mean, if we were to show the work, we are going to say that when x is greater than 2x naught and less than, I would say, 6x naught, right? The force is the force is 2 u naught over x naught. So 2 u naught over x naught. Um, where are we going to draw it? Let's keep it on hold and let's find the other one as well because we will draw it relatively to each other. So this one is of course again rise over run. So we're going to say that when x is greater than 6x naught and is less than 8x naught, the rise is from negative 4 to negative 2, correct? Negative 4 to negative 2. So that's a 2 u naught rise, and there's a run of 6 to 8, of course. So that's a 2x naught, which is going to be just u naught over x naught. But remember that there will be another negative. So I'm going to say that f will be negative of this and negative of this. So clearly, this is double the magnitude of this one. So if I were to probably draw that as at the 4 mark, so I'm going to say that this is going to be like this, and then the 4 mark will continue till 6x naught like this. This is 4f naught, so this is definitely going to be half, right? Because if this is twice of that, this is half of that. So half of 4 is 2, but not positive 2. It should be negative 2. So negative 2 is somewhere over here. So we're going to drop down and then we're going to go forward like this. So this is going to be our answer for this question. Okay, in another scenario, object A is replaced with C. C and B interact with each other through a conservative force this, where beta is 3 over 8. The potential energy between CB is defined to be 0 when object C is at negative 2 meters. Okay, all right. No external forces act on the system as well. Derive the equation of UBC and express your answer only in terms of x. Begin your derivation by writing a fundamental physics principle or, okay, basically going to rewrite the same equation and then integrate it. So FC we know as negative du over dx. So I can rewrite this as du is equal to negative fc dx and then integrate both the sides. In this case, the bounds are from the lower bound of x is negative 2. At negative 2, the u value is 0. That's given in the question. Upper bound is x, and at x, there is some other u energy that we need to find. So the left side with just integration of du is just u from 0 to u. And this will be negative integration of negative 2 to x. F is negative of beta. Beta is 3 over 8 and then x square and then dx. I hope you are able to follow. FC is just replaced with this entire thing. The left side will just become upper bound minus lower bound. Double negative is positive and 3 over 8 comes out and the integration is from negative 2 to x of x squared dx. That's about it. Integration of x square is x cube over 3. We put the bounds from negative 2 to x. 3 and 3 is gone. So u will become 1 over 8 upper bound minus lower bound. So this will become, finally, u is equal to 1 over 8 x cube and negative 2 cube is negative 8. So double negative is positive. So this should be our final answer.